Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Dual Protection Mechanism for Ensuring Data Privacy and Integrity in Network Communication. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I am to present you one of the system that we have designed in the domain of the research for the data privacy, where we are ensuring the network communication with the secured communication. So in this particular video, there are multiple sections that we are going to cover. Let's talk about what sections we will cover. Initially, we will talk about in which application areas the design system can be implemented, where the proposed system will be helpful. Then, whatever the code we have designed, how to execute it, what are the software requirements for it. Next to that, what are the current systems, those are currently working in the same domain, and the challenges that they were following, and what proposed method is doing in order to handle it. Finally, the experimental outcome and findings will be shown. So let's start with the application areas. As we have designed one data privacy and encryption methodology, so this is related to the security purpose specifically, as there are certain platforms on which the currently data communication has been done, as like IoT, where the census data is crucial specifically for the medical domain, military domain, the data which is not to be accessed by the unauthorized person. So as the data is transferred over the internet, so it should be secured and can be safely reached to the destination. So internet security, digital security, as for the banking sector or many other sector where the transactions or the financial systems are involved, there the handling the data with the secure phases is very important. So for the data digital security, as well as your credentials like any thesis, any research, or any confidential information which is not to be in the unauthorized person hand. So the data protection and the network security, so these are the domain where the developed system can be implemented. So now let's see what exactly we have done and how to run the code. So you will get the folder like this, where you can see there's a folder named code. When you will open this, you can see there are a number of files with us. So the whole code is implemented in the MATLAB, so you must have the MATLAB software with you. The MATLAB version that I'm using is to R2019A. So you can use 2015 or above, but it should be the full version, not the trial version. So in order to run the code, you just need to go to the folder where the whole code has been placed, and you just need to copy the path. And when you will copy the path, just go to the MATLAB and paste it here. The path will be given here, press enter. All the files you will see in the folder will be shown here in the current folder. Now you just need to open the main file and the test file. Test file is for a single scenario, for a static one. Main is for the generic one, where you can give the random data or the data of your own option. So in order to run the code, you just need to click on the run button and it will start executing the code. So here you can see when I just opened the code, it moved from home to editor, where you can get this play button. So you just need to click on this main and it will start processing the things. Now let's talk about what exactly the current system and what we have done. So we were referring many of the papers for the research purpose, and we have seen that many of the encryption algorithms has been implemented. But basically in the cryptography, they are doing like working with the cryptographic algorithm like ECC, RSA, AES, and many others. Like they were just doing the data encryption. But the main challenge is, like, as the current systems requirement is to reduce the storage also, that is the problem that we identified. Other than that, the system should be like that, it should be overcome the issues faced by the current methods like ECC or RSA and many others. So the methodology that we have defined is basically proposing one encoding and encryption based methodology that provides the dual security to the data. Also, we are improving the traditional ECC method by introducing the key generation method through the Diffie-Hellman key. So what we have done in this, initially we have generated the data, we have kept it random or the user defined so that we can test it on different scenarios. Then in that simple scenario, we have generated the key by using the ECC's traditional method, and then XOR with the binary data that we have generated at the initial stage. So this is the basic method, and we also say check that how much time it is taking to encode by using the traditional method, which is generally used in the current scenario. In the proposed method, initially we have applied the encoding scheme. So that is basically the Huffman encoding scheme we are applying, that is helping in encoding the data from one form to another, which is also a type of encryption. And secondly, it is reducing the size because the encoded data is giving us the less data. So you can see when I just ran the code, we do have the information with us where they are showing that how much data was initially and what are the, here I have just printed that how much length of the data was actual. So actual was 5000. So the proposed length of data after the Huffman is 49875. Few of the bytes has been saved. So that is the compression, that is the size. So then what we have done for the encryption, so second stage of the encryption, we initially generated the key from the Diffie-Hellman key. So the function of this Diffie-Hellman key algorithm is given here. So you just can double click and open it, but this is the function that we called here. So it is giving us the key, which is further used for encrypting with the ECC. In the traditional ECC method, the key generation method is using by the basic scenario or the ECC itself key generation method or the static keys. So here we are using the Diffie-Hellman key generation, so that easily the person cannot give any of the key. It should be some algorithm oriented. Then ECC is encrypting as per its standards and finally giving us the output. So encrypted data is there shown, and then we have shown the encrypted data, as well as we have checked further parameters like what is the correlation among the actual data and the encrypted data, so that we can check how much variation is there with respect to the initial and the encrypted data. Then decryption has been done in order to see that what is the recovered data, and then the factors that we have analyzed, like what is the actual data length, how traditional method is giving us the length, what the proposed method is giving of the length, because obviously Huffman encoding is going to reduce it. Then key generation time has been seen. So you can see the key generation time of the traditional method and the proposed method is very less, because it is taking 0.19 of the second and it is taking 0.1 of the second. Then encryption time with the traditional method and the proposed method, it is around taking 0.3 of the second, and it is taking 0.007 of the second. Then similarly for the correlation, you can see when we were doing the encryption with the traditional method, it is somewhat correlated with the actual data, and it is 0.99% similar in the correlation factor, where in our method there is a huge variation because encoding is also introduced, so there is a variation among the correlation. Then encoding and the decryption time is also shown. So this is what we did in the proposed method. This is the scenario when the random data is generated, because the text we generally used to give is within the sky code range. So we are also giving the option where the you can comment this and you can directly give the data size from here. By varying the data, you can analyze the output. One of the scenario we have taken where we have given the text manually, you can change it as per your requirement. So if you are going to click it, it will execute the process for this given input and calculate the results. So you can see in this scenario also the proposed method is performing effectively even in the time as well as for the variation in the data. So let's see what parameters we get. So this is the parameters for the data count, actual length, traditional encryption method, and the proposed encryption method. So data count is going to be reduced up to 50%. This is the time, key generation time. Here you can see for this particular text, the key generation time for our is like here let's see the encryption key generation time. So this time for this particular data, it is around 0.007. It also depends upon the resources of yours. Further to that, you can see the time for the encryption, it is very less in our scenario in respect to the traditional one. And finally the correlation means the relation among the actual and the encrypted data, so it is very less in our scenario, so provide more security. So further modifications are still possible into it. So for those details, you can contact us directly. Even industrial purposes or research purposes are the domains where we are currently assisting. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.